Hi everyone, welcome to our next video in the Week 1 series where we'll be talking about stem and leaf plots. This corresponds to the first section of 2.1 in your textbook. A stem and leaf plot, sometimes called a stem plot, is a graph used for small single variable data sets. Statisticians like stem and leaf plots because they are typically easy to create in terms of a time investment. If you're a researcher in the field, this is something that's easy to do on a scrap of paper without a lot of resources. It consists of two pieces, a stem and a leaf, thus the name. The stem is the leading digits of the number. The leaf is the final significant digit of the number. So this is small single variable numeric data. For example, we have the data set shown below, 10, 12, 15, 15, 17, 18, 21, 22, 22, 22, 22, 25, 28, 29, 32, 36. And we want to create a stem and leaf plot for that. So first I create a graph. Typically you'll see this as a T-chart. There'll be the typical T that divides the stems from the leaves, and then an underlining of the titles. I've made it into a nice pretty table because I'm using Google Slides. And then you look at your numbers. I know that I need 3 rows in my stem plot because looking at that data, there's only 2 digits. So the first digit, the one in the ones place, is my leaf, and the tens digit is the stem. So leading digit is the tens place, the final digit is the ones place. And looking at the tens place, I've got 1, 2, and 3, tens, 20s, 30s. So my stem is going to be 1, 2, and 3. The leaves are the trailing digits, the ones place. And we sort them by stem, so all of the ones are going to be in the same group. All of the 20s are going to be in the same group. All of the 30s are going to be in the same group. And we list them in order from smallest to largest, and we include repeats. So I've got 2 15s. I should have 2 5s in my leaf row. So let's go ahead and start. I'm going to start with my first number of 10. This data set's nice because it's already sorted from smallest to largest, and that makes our job easier. So for 10, the stem is 1, the leaf is 0. So 1 and 0. Moving on to our next number of 12, we get a leaf of 2. 15 and 15 are 5 and 5. 17 and 18. When I move on to my next number, I need a new stem, which is 2. And when I get through all the 20s, I can see 21, 22, 22, 22, 22, my repeated 2s, 25, 28, 29, and then that last row starts here with the 32. So this is something that didn't require a calculator. I just took my numbers, I peeled off that last number and dumped it in the leaf box, peeled off the first number, dumped it in the stem box, and I made sure my leaves were in order from smallest to largest and showed repeats. That repeat is important. That middle row, my 20s, that would look a lot smaller if I didn't show that repeated 22. There's actually a lot of data in that middle row, but if I remove the repeats, it wouldn't look like it. So those repeats are important. They help give us an idea of the shape of the data, and that's some of why we use graphs. So I can see I've got a fair amount of data in the tens. I get a nice pretty peak in the 20s, particularly around 22, and then a little bit of a tail in the 30s, but not a whole lot of data here. Okay, so when we look at stem plots, we need to talk about something else that sometimes occurs in stem plots and becomes very visible in those types of graphs, and those are called outliers. So outliers are data values that do not fit in with the rest of the data set. So if you're looking at them in a graph or in a sorted list, they look like they don't belong. You'll also hear them called extreme values because that's what they are. They're values that are too small or too big to reasonably fit in with the rest of the data. We can use stem and leaf plots to help identify potential outliers. This again is a potential list. We will talk later about how to calculate whether a value is an outlier or not. But this gives us a potential list to then check later. So here's an example of a stem and leaf plot. I can see it looks kind of like the one we just did. We have a row for the 10s, the 20s, 30s, 40s, 50s. So I've got data values of 11, 12, 20, 22, 22, 24, 28. And then I don't have anything in the 30s and 40s. And then I've got the number 54. So looking at this table, I can see that 54 is a potential outlier. Everything else is in the 10s and 20s. That 54 is way out there by itself. So that's likely an outlier. Okay, so this is a try it. I'm going to read through it, and then after I've done that, I'd encourage you to pause the video and try and do this on your own really quick before I go through the solution. So try it 2.2, the following data show the distances in miles from the homes of off-campus statistics students to the college. Create a stem plot using the data and identify any outliers. So they want you to create a stem and leaf plot, and then just like we saw in that last stem plot, see if you see any outliers that are hanging out at the beginning or end of your graph all by themselves. All right, if you want to try this on your own, go ahead and pause the video. I'm going to go ahead and move on to the solution. So you can see my stem and leaf plot here. I created that in GeoGebra. You will notice that there's a key here, which is important. This data, I have my stem in the ones place and my leaf in the tenths place. So this key tells anybody looking at my table that that first row is 0.5, not just 5. That second row is 1.1, not 11. So that dividing line is where the decimal point is. You will notice that GeoGebra doesn't automatically label stems and leaves, and that's okay. I would encourage you, if you're doing this by hand, to continue doing that. It is considered good form. But I see two interesting things here. I see a very nice clear peak at 1. There are more values in the tens or the ones category than anywhere else. And then I also see that 8.0 is hanging out here at the bottom of our table by itself. There's a gap of like a little over 2 between the next largest value and 8.0. So I suspect 8.0 might be an outlier. Okay, if you have questions on how to create a stem plot or how to read them, please let me know. Otherwise, I will see you in our next video.